Welcome, Calculus 2 students. We are looking at other integration strategies today. The first of which is using tables, which is really cool as long as you have your table of integrals. You have to look through piles and piles of them and find something that matches what you have. This one I've done for you. This is the one that I found that matched, and I snipped it and put it in here. In this particular case, my A is going to be 2 and my B is going to be 9. So all I have to do is just write 2 over the square root of B, so that's the square root of 9, which is 3, inverse tangent, square root of, and then that's 2x minus 9 over B, which is 9. And then plus C, I guess I could clean that up a little bit, take it out from underneath the square root and make it a 3. Other than that, this is what it's going to look like. Okay, for my next one, you're not going to be able to find one that matches this exactly, so what you're going to have to do is complete that square and get it so that it looks like an x squared either plus an a squared or an x squared minus an a squared. So I'm going to complete that square. Alright, this is what I get, so let me go get my table of integral solution. Now this is what I'm shooting for, where in my particular case my u is an x plus 3 and my a happens to be this 3. So, but that's already been plugged in for me, so I'm good. So I'm going to have an x plus 3 over 2 square root of x plus 3 quantity squared minus 9 minus 9 halves natural log of this x plus 3 plus square root of x plus 3 quantity squared minus 9 plus c. And isn't that lovely? It is just lovely. Does it simplify? Not really. Okay, on to the next one. Another area under the curve. So I'm going to do the area under the curve from 0 to pi, and this is what it's going to look like. I found a integral in my table of integrals. For my case, a is 1. Okay. So let's plug this in. For a is 1, I'm going to get negative 1 over 1, so I'm not going to write that, tangent of pi over 4 minus, and that's x over 2, because that'd be a 1, evaluated from pi to 0, and I'm just going to chunk that in. Alright, we use the table of integrals and then we just plugged in and I get a value of 2. Seeing as our next topic is entering into computer software, I'm just going to use your TI-84. I'm going to do a numerical integration, and I just hit my math button on my calculator and then go to this numerical integrator right here. This is what I would plug in, and notice that I get the same value, which is a 2. So as long as I'm wanting just a numerical answer, this will work for me. If I was wanting an analytic answer, I would have to use some sort of tables of integration, but I thought I would go ahead and show you that for this one and for the next one. Alright, I keyed this in for the next one. You'll notice that I have the integral of from 0 to 1 sine of x squared, and I get 0.310268, and as long as all I want is the numerical answer for that, my calculator does a very nice job. Now, there are other sorts of computer algebra systems such as Maple and Mathematica and MATLAB. You're not required to use those for this course, so any of the problems that involve an analytical computer integration you won't be required to do for this course, but the numerical, you can enter that into your TI-84 equivalent or equivalent calculator. Alright, lovely. If you have any questions, be sure to see me at the Collaborate. or email me.